Hello everybody. In this video, I initially had planned to just show ESP32 to ESP32 communication through Wi-Fi. But I got from the previous video so many requests to expand the web server functionality that we'll do that first. I'll also make this video about ESP32 to ESP32 communication, and as soon as that's available, I'll link it above. But for now, this video will focus on the web server. And in particular, if you look here on the screen, you'll see the connection that we're going to make. So we have ESP32 connected to the Wi-Fi, your local router or whatnot. And then any other device connected to that Wi-Fi can navigate to the IP address of the ESP32 with a web browser. And in that web browser, you'll then get a screen, as you can see on the left top, LED controller. And you can now assign an LED to be on. And as you can see, the LED then switches. You can also set the intensity, very bright or very low. And so you can control anything that's connected to that ESP32. In this example, it's just 3 LEDs, but I'm sure you have more useful applications yourself for this. So you might notice, okay, I need a router right now to set this up. That's true in this particular case. However, you can configure the ESP32 as an access point, and then the client can directly log into the ESP32, so you don't need a router in that case. I'll plan to do a quick video on that as well, and as soon as that is available, I'll link it above. All right, let's get to it. Now let's start on the GitHub page where I posted all the code. If you just want to download the final result, then the relevant folder for you will be ESP32 Wi-Fi Part 3. I have a direct link of that in the description below. However, if you want to code along, then our starting point is ESP32 Wi-Fi Part 2. So we'll open this. As you can see, there's 4 projects in the Arduino file. The one that we will use here is the ESP32 web server WebSocket JSON. I assume that you're familiar how to set up a web server on the ESP32 and work with WebSockets and JSON. If you're not, then please first watch the part 2 video where I explain exactly how to do that and how to get to this particular code. So the link for part 2 is now on the top of the screen, or you can just look in the description below. Let's first update our HTML file. The HTML file we have over here is the one we ended up with in part number 2. So that's the one where we were focusing on a random number generator. Obviously, now we want to control LEDs, so it needs to look different. I opened therefore the HTML file in Notepad++, but feel free to use whatever editor you would like to use. Now we don't want to create random numbers here, we want to make an LED controller. We don't need all that stuff over here, let's just delete it straight away. I assume that HTML will be well known by most of you, so in order not to get too long of a video, let me just copy paste the HTML in and then explain that briefly. So we see here that we have 3 radio buttons and they have IDs. And those IDs are really important because with the JavaScript, we can refer then to the radio buttons through the ID. Then we have a slider, and the slider as well has an ID, LED intensity, and it has a range from 1 to 100. You can change the range as you want, obviously. The standard value is 50. Then finally there's a value, which is just a numeric representation of the slider, if you will. And that can, of course, not have the same ID as the slider, so I just called it over here LED value. So we'll refer to those later on with the JavaScript. So let's just save this and briefly check if this works. So to do so, you just open a random browser. I use Chrome, and then drop the HTML file in there. So we'll just drop it in and we see, yes, we have an LED controller. We see straight away that there's no LED selected and that there's no intensity level set and that the numerical representation of the slider isn't filled in. That will all be done with JavaScript, so that's up next. So going back to the HTML file, we'll now fill up the JavaScript. JavaScript below was again for the part number 2. In this section, we won't be needing this button send back anymore. Let's just delete that straight away. And we'll start with the radio buttons. Now, to make the radio buttons work, we need to create what they call callback function. So whenever someone clicks a radio button, it can then refer to that particular function. That is done by first getting the element, and we do that on filtering the element ID, LED 0 first of all, obviously. Then we need to add an add listener event. It's an event that you need to first define when does it need to go to this callback function. So you want to go to the callback function whenever someone clicks on it. And then you can give it yourself a name. So let's just do LED changed. Yeah, that should do. We need then the same for all the other radio buttons as well. So also for LED 1 and for LED 2. Then we can also define the callback function. So we'll do that here with the functions below, and we create a function. We called it LED changed, and it will do something. So what we see though is that every time a radio button is clicked, then the LED changed function is called. You could also make this LED changed 0, 1, and 2 so that you know which button is called when, but I just prefer to just have one function so that's easier to make changes later on. In this particular function, it's relatively simple. We just assume that the first LED is selected. So we make a variable and we say LED selected is 0, and then we just check if any of the other radio buttons is selected. So document.get element by ID. Obviously you could do this with variables as well, but to keep it simple, I just left them out for now. And we just see if the first LED is selected. And if it is selected, then we change the LED selected value to 1. Else if, of course, document.get element by LED 2 checked is true. In that case, the LED selected equals 2. Now what we can do as well is we can briefly see which LED is selected, and you can write to the console. So you can write just console.log LED selected. Now what does that do? Let me just show you that. Let's save this file and just throw it into a browser. So here again, same browser. I could also just refresh this, but just for sake of simplicity, you just slide it in here, and then you press F12. And okay, it will give you an error because obviously we don't have a WebSocket set up. It's not running on the ESP32, it's just running on your local PC. But if you now press a radio button, then you'll see 0, 1, and 2. So anything we write in console.log can now be seen in that debug window. So we know this is already working. The next step, of course, is that if a radio button is selected, if you select a new LED, that this value is also transferred to the ESP32. But we'll do that logic later. Let's also put some life to the slider value. So for the slider, as we need to set the slider as well, we need to create a variable in this particular case. So we do that for var slider is, and then it's the exact same thing. We refer to the ID of the slider, and that was LED intensity. That's it. Yeah, we have now the slider, but we now need to also set up a callback function. So setting up the callback function, we could of course do again document.getElementID, add listener event, etc. But as we already defined the getElementID for the slider in this variable slider, we can straight away just say slider.add event listener, and then it's the same thing. Whenever you click on it, we want to run a function, and we call that slider changed to be consistent. So let's add here a function as well. Function slider changed. So in this function, let's start by creating a local variable to store the value of the slider. So we can do var LED intensity, for instance, but wait, this is confusing because we used LED intensity already as an ID before in the top. So we should fix that. Let's perhaps call these local variables something like L underscore LED selected. That makes it very unique, and you know straight away it's a local variable that you have. So here we could just say local variable LED intensity. Then it's not going to be confused with the ID that we had above. That's always a bad idea. So we want this to be equal to the slider value, and then we can write this to the console. Okay, and that should do. So now we can test if this works as well. And if I now change the slider, you can see in the console the number going all the way from 100 to 1. So, okay, that works. So the next thing we need to do is communicate with the ESP32. Now let's start here with the LED changed. And we're going to do this exactly the same as what we did in the last video. So we create a message and then write parameters in there. We'll take one parameter for the type of message. We could call that something like LED selected. And then the second is then the actual value. So let's go and do that. Variable message. This type now defines really that I can call this anything, but I call it now LED selected. So in the Arduino, I can filter on this. And then if I see LED selected message, I know, okay, the actual value of this message is going to be the variable. And when the variable we called L underscore LED selected. The same, you can just copy paste this whole thing. The same we do now for the slider. And then obviously we say LED intensity. And this is then LED intensity. Okay, that was simple enough. Now, what we're going to do in the ESP32 is that we're now going to receive these messages and then send it back to the clients, to the web clients. The reason for that, as said, is to make sure that all the web clients have the same information. So we need to be able to receive this information as well. And that we do in this process command function. Why is that? Well, if you go here to the top, then we have here this init function where we define our WebSocket, and we say whenever you receive a message, you need to run the process command function. So that's the function down below. Oh, and by the way, I do see that there's still a line of the old code we definitely don't need. We used to have a button called button send back. And so we had this get element by event listener there. We don't need this. So let's delete that. Good. Let's write now the process command function. So the first line is already there for the process command. It defines an object and parses the event data. So whatever data we get in, parses it in the JSON format into that object. So we have an object we can read out. So we don't know what kind of message we're going to receive. And you can't just read out the JSON file if you don't know what type it is. So if you don't know whether LED intensity is sent or LED selected. And that's why here we first define the type of the object, and then we compare. We look at whether or not LED intensity or LED selected is contained in the message. If these are contained, then this compare will equal 0. So the upper one will be true if the LED intensity is sent, and the lower one will be true if the LED that is selected is sent. Now, if the LED that is the LED intensity is sent, we want to, of course, update the slider value. And so what is the slider value? Well, let's create just again a local variable with the LED intensity. And this one is going to be equal to object.value. And we can then write it to the console. So just for debugging purposes. And we can write it to the slider, of course. That's the main idea why we are doing this whole thing. But in addition, we want to also have a numerical representation of what the slider value is. And for that, we had prepared before the, let's see, over here, this LED value. So we can make, now that's not the slider, then it's another variable. Let's just call it output. It's the numerical output of the slider, really. That is document.getElementById. And then this is the LED value. So that is this parameter over here. And we can also now write it to the output. So we say over here, output.value is equal to LED intensity. Good, we're done with that. Let's have a look at the LED selected. And that will be the object.value. Actually, strictly speaking, we want it to be an integer, and we're receiving probably string. So it's probably better to parse this as an integer like this. I think it will work without as well, but just in case. And so we could do that over here as well, of course, with the LED intensity, parse integer. Just in case. Okay, so then, yeah, obviously we can write it to the console. It's almost the same as over here. Just copy paste it over. And then we'll need to check which LED was selected. So if the LED selected is equal to 0, then we can select that radio button. And otherwise, let me just copy paste this whole thing over. We'll need it more times. Otherwise, if the LED selected is equal to 1, then we need to select LED 1, obviously. And finally, if it is equal to 2, we select LED 2. Good, covered that. So actually, before we continue and go to the Arduino, I noticed a mistake over here. Look how I in the slider changed, I now created a message and then kind of forgot to send it. So let's go and do that. We need to, of course, send the message now to the ESP32. And that is done with the socket.send. And we do need to then put a stringify on that. So json.stringify and then the message. This is, of course, exactly the same as what we did in the previous video. So again, just refer to that if you have problems with that. And I see I was smart enough to also forget that in the LED changed function. So let's copy paste that over there as well. Good. Then I think we should be all set. Yet another mistake. This output over here, see the slider is a real object and has an actual value, but I think the output is just a span. Let me just see. Yeah, here see the output is just a span that has an ID, and then value won't work. That it should be something like inner HTML or something like that. Let's see, where was it again? Here, output.value should be outer.inner HTML. Then I think it should work. Another thing I'd like to point out is that I escaped the quotes over here. I didn't comment on it earlier, was too busy writing, but the reason for that is if you wouldn't escape the quotes, so escaping means that you put this backslash in front of it, then when we copy paste this now into the Arduino as a compressed HTML string, the Arduino code would think that the HTML ends over here. So basically in the Arduino environment, we have then this very, very long string, and somewhere over here you'll find, and so here for instance, we see then the LED intensity. And if I now would remove this backslash, then you see straight away that it thinks now that the string ends over here. Another thing I'd like to warn for in the Java environment is not to use comments. So in Java, it's quite common that you can just add here some random comment, test 1, 2, 3, and that will work just fine. But if we now compress the HTML, so we put everything in one string so that we can port it into the Arduino environment, this won't work. In this particular case, you'll get this result. So the whole code is in just one single line. So the end of line characters are all removed. Then the Arduino will still compile and throw this to your browser, but your browser now really doesn't know what to do. Look here to that comment test 1, 2, 3. So we see here with the semicolon that the previous instruction is then terminated. But then here's our command test 1, 2, 3. And there's actually no separation now between our added command and the next instruction, which is socket on message. So that's where your JavaScript just won't work anymore if you don't have these end of line characters in your code and you're using comments. So let's just leave that out. Okay, so with that, we can now select, and I should remove this, of course. With that, we can now select everything, compress HTML, and start with the Arduino code. Again, this is explained in part 2. So we have now updated the HTML, and that means that whenever someone changes a radio button or an intensity, these values are sent over to the Arduino. Now we can get rid of this interval stuff because we're not going to do anything with that anymore. So that can go. Of course, we need still the WebSockets and everything else around that. And we'll just navigate down to the area where we're sending stuff and receiving stuff. So here it periodically checks the time and then updates the random number as we did in part number 2. All that stuff can go, and really the loop section is going to be extremely tight. It is just waiting for one of the clients to do something, change an LED or something, and will only react to that. Then when we look at the WebSocket event, so whenever some information is sent from the clients, then obviously we need to change that. And here, when we receive it, it just says someone's connected or disconnected. And then this WS type text is when some actual JSON information is received. That is now where we need to evaluate what type of information was received. So here with when we know that we have valid JSON information, there we can now decipher the type and the value that we defined before. So we have a char that we call L type, and we have then a constant integer, which is the local value, and this will be the value. Those are the two parameters we get from JSON, so we can simplify this tremendously. And just for debug purposes, let's just throw these on the serial port and then see if everything's working. We can print the type of message received, which is local type, and we can print the value we receive like this. So the other two we don't need. That should do the trick. So now that that's programmed, I can open up the serial monitor. Let me get it on the screen for you. And one of the browsers. So if in the browser I now navigate to the IP address of the ESP32, then we get this LED controller. We straight away see in the debug interface that client 0 is connected. And if I now select an LED, then I see here I get a type LED selected 0 or 1 or 2. And it can also set a value. And whenever you set a value, you get LED intensity, 80, 1, 100. So the idea now would be to write this back to the clients. And why is that? Well, you might not just have one client logging in on the ESP32. You might have two clients on the ESP32. In that case, if one of the clients changes the LED port, then the other client doesn't know about it. So it's really important that whenever an LED port is changed, that value is written back to all the clients, that all the clients are updated at the same time. So let's go back to the code, see what needs to be done. The one thing we want to do is just write back the code to the clients. So whenever we receive something, we first want to interpret what has been received and then write that locally on the ESP32 memory. So if, for instance, the L type, the type of the message, was equal to LED intensity, then we know that the intensity needs to be changed and we need to interpret that. And we could, for instance, make a variable LED intensity for this case and say it is equal to the local value. Now, in the code I'm writing here, it's really important that you notice the casting that I do. So I don't just compare this constant character with LED intensity. I cast it to a string. Otherwise, this if statement won't work. So it's really important. And similarly, this value over here, I just state once more, this really is an integer, not a constant integer anymore. I'm not sure if this is 100% needed, but just to be safe, I just added it in. But now I'm using here a parameter that I haven't defined yet. So let's go ahead and do that on the top. Okay, so over here somewhere, maybe here, we can just add some global variables, and that is the one that we had, the intensity, and let's just make it 50 or something like that. It needs to be, of course, somewhere, some value that the slider can support. And while we're at it, we might as well add another variable for the LED selected. And we'll just select the first LED per default. So we've now received the intensity, and the one thing we need to do is send it now back to the clients, as I explained earlier. So for that, let's make a small little function, because we'll need to do that quite a few times. So we'll call the function send JSON or so. Oh, well, not that many capitals. Send JSON, and we'll give it two parameters. So the first one will be the parameter that we're going to change. That is the LED intensity. And then the second one is the actual value. Over here in the bottom, we can add the function. So it's a void, obviously, we're just sending stuff over. Send JSON, and it gets a string first, which is the type, and then a string, which is the value. Okay, I sped that up a little bit because, of course, this is in essence the exact same function as we already saw in part number 2. Bear in mind here, we're sending stuff, so it's the doctx that we're using. We use the docrx for receiving, as you see over there. Okay, so we now have this function where we can just straight away send for the type, that's the first one, it receives the LED intensity, and then for the value, the local value. And we basically need to do the same for the LEDs. So okay, so now we have the exact same code for the LED selected, where we just interpret it and send it back to the clients. There's one thing though, if a new client comes up, then that new client doesn't know which intensity it has at the moment or which LED is selected. And so we kind of want to add that too as well with the WS type connected. So I already wrote here, optionally you can add code here what to do when connected. So as you can see, this is exactly the same code as we wrote here below. So just to inform the new client what the intensity is and what the LED selected is. Okay, there's one thing I see I misspelled. I see here LED select, and this should be LED selected. And over here in the bottom as well, this as well, send JSON LED selected. With that, let's compile this and see if it runs. So here we have two clients and the serial interface of the ESP32. I just only reloaded the pages like this, and you can see straight away if you reload them that the clients are connected and that automatically the LED, the right LED is selected and the right intensity level is selected. And if I now change the LED, then you see that on the other client, automatically the LED is updated as well. Or if I change the value, you'll see the value is updated on the other client too. Now the last part we need to do is just put the LEDs on and off. That's super standard stuff, although with analog writes, it's slightly different on the ESP32 than on the standard Arduino. So we'll briefly add that code in. I'll keep that really short because this is already a pretty long video. So here we go. So of course we need to define which pins we're going to connect the LEDs on, and in my case I'll connect them to pin 4, 0, and 2. So just as a fresh up, in order to connect an LED, of course, put a resistor in serial with this. It doesn't really matter which resistor you take. Something around 100 ohms should be fine. So port 4, 0, and 2 are oriented like this on the ESP32. And so from the resistor, you go to the LEDs and then to a common ground. Now, in order to do analog writes on the ESP32, you need to define channels. And so here I define channel 0, 1, and 2 that will represent pin 1, 0, 1, and 2. You need to define your resolution of your digital to analog converter. That is going to be 8 in my case, and a frequency it's going to work on. Doesn't really matter. I just chose 5000 here, which is pretty much a standard value. Then in the setup, we need to initialize the channels. That is done with this LEDC setup. So we have here the LED channel 0, 1, and 2. We define the frequency and the 8-bit resolution. After the channels are initialized, we then need to bind the pins to those channels. It's a little cumbersome with the ESP32, but yeah, that's just the way it is. So LED-C attach pin, and then you define the pin and the channel number. So that way you could also attach multiple pins to the same channel, which of course we're not doing in this case. So then basically the pins are all set up and we can directly write to the pins. So here right below send JSON, that is where we need to do an analog write to the ESP32. But with ESP32, this goes slightly different than with the standard Arduino. This is called LED-C write right now, because we need to write to these channels, right, that we defined. And we can just define the channel, and that is this array of LED channels, and then the selected LED. And then we need to map briefly the LED intensity because, wait. And the reason for that is that our sliders are defined from value 1 to value 100. But the output port of the ESP32 is 8 bits, so value 0 to 255. So we need to briefly map that. And so with the map function, you first have the input range. I do here from 0 to 100. Our slider minimum is 1, but that always means that the LED is slightly on in this case. And then we go to 0 to 255. Okay. And then for the radio buttons, which LED is selected, this in essence is the same. We just need to briefly cycle through all the ports and make sure that the correct port is on. So if the LED is selected, so I wonder why I chose here LED select as the name for this variable and not as in the JavaScript LED selected. I'll correct that in the final code for download. Anyway, here we do as well the LED-C write. And we now select LED-I. And we again map this LED intensity. And else, if it's not selected, well, then we just write 0. So this takes care of writing the new state to the LED as soon as it's changed. The one thing we didn't do yet is define the intensity of the LED when we boot the ESP32. So we do that by just copy pasting this command, going up to the setup, and in the last sentence of the setup, throw this in. So that whenever the ESP32 is reset or is started for the first time, that the first LED goes on. All right, and with that, we can compile and see how it runs. Okay, so here we have 2 clients and the serial interface, and in addition then the camera to show the LEDs. Now if I change the LED selected on any of the clients, you see the feedback in the serial interface, you see a different LED selected, and you see it on both clients. Also I can change the intensity from very high to very low. So we have a working system with that. Have fun with it. As usual, leave your comments down below. I very much appreciate all the feedback and responses I've gotten so far, and see you in the next video.